How to restore a tube radio, step 1. Good day and welcome back to Mike's Radio Repair and Restoration. We're going to start a new series on restoring tube radios, step by step. And the first thing we're going to cover is safety. That if you're following along at home, understand you do so at your own risk. There are voltages in these sets that are dangerous all the way right up to lethal. So you need to kind of sort of take some steps to protect your safety. Again, you follow along at your own risk. This channel has, for long since it started, always been focused at the newcomer to this hobby. And who is the newcomer? The newcomer is somebody who wants to restore some tube radios, who has a little bit of electronic knowledge and a little bit of electronic experience. I know a lot of the folks who watch this channel are 50 years or older. Maybe they built some Heath kits back in the day. Maybe they tinkered with some 741 op amps or any 555 timers, some transistors, and they've got a basics, nothing crazy of electronics. And having this little bit of basic skills goes a long way to also protecting your safety. Now, I take a lot of flack from the older folks who've been doing tube restorations for a long time because I'm not teaching rocket science, and I don't intend to. I intend to teach this very basic and learn people to get up on their feet and get moving and understand what's going on. And as you get further and further into this, rocket science will come. As you're replacing components and looking at schematics, you'll begin to understand how things operate. You'll get curious. You'll do some more searching. You'll get into the Ohm's law maths. It will come in time. So I start out with the very basic. It is not my intent to swamp you with too much information that you can't understand or can't digest in a hurry. So this step system that I have put together here, and I've worked it a few times on my channel, is designed for the beginner, and it's designed to ensure your success, or at least get as close to it as humanly possible. So this step system is pretty easy to follow, and I'm going to take you through it with a radio now. Now, with that in hand, I've posted some links below in the description of some basic stuff before you really get into this. You should watch. If you're new to this and you're new to the channel, you might want to watch all the videos that I've posted below before you continue here. This will give you a better foundation to build on, having this knowledge that is presented in these links to you. As I said, the step system is kind of sort of engineered to ensure your success. And this first one, we're going to go through some essentials, and I call this step 1. So let's get our victim up on the bench and start step 1. Okay, here is our victim. This is a Hallicrafter model S40B. Now, before I get into this, if you've dragged home an old radio, resist the urge to plug it in. There are some steps you have to do before you can plug it in. The chances of damaging something, they're there. Sometimes you won't, and sometimes you can. If the filter capacitor is shorted, burning out the high voltage transformer is a possibility. If there are old wax paper capacitors in it, smoking an IF transformer or smoking the audio output transformer are all possibilities. So there are some steps you want to do before you plug it in. So resist the urge to plug it in. And we'll go through the steps of what you need to do before you plug it in. So let's get back to the Hallicrafter S40B. I like teaching with these radios because they are simple. They're reasonably well designed. It's not perfect by any stretch of the imagination, They're easy to find, and they're affordable, to restore. And once you restore them, they give a great amount of enjoyment. Um, Now, I have an S40, which is the original S40 line, and an S40A, which is the second rendition. And now I don't have an S40B in my collection, so I picked this up for $25. And I did so because I gave it a look over and it looks fairly complete to me. We're going to go through this right now. And this is part of step one, is assessing the cosmetic and completeness of the radio is part of step one. So just by looking at the front panel, we've got all of our knobs here, but I'm not 100% sure if this is original. I gotta take a peek and have a boo and see if this one is original. Now, just one of the features that's nice about the S40 line is they have a BFO, a beat frequency oscillator, which is handy because you can trick and sneak and listen to single sideband using the BFO. So it's nice to have the feature of this radio. But looking at the front panel, yep, it sure is dusty. Yep, it sure is dirty. But I can also see there's very few scratches, so I know it's going to clean up nice. I can pull all the knobs off, put the knobs in the ultrasound, and have them come up nice and clean. The case isn't bad. Okay, it's quite presentable. So I know cleaned up, it's going to look reasonably well, and I think for $25 it was a good find. Now let's just pause for a second and take a look inside the chassis. So what we are doing now is we're looking for broken stuff or problems that are going to bring our restoration project to a halt before it even begins. So there's some certain checks and balances we do before we go crazy and start throwing new capacitors in to ensure ourselves that we're going to have a working radio at the end, or at least as close as we can get. So we're going to go through some steps to prove or deny that the radio is worth restoring. Now, one thing I have noticed already with this radio, I don't know if you can notice it on camera, but none of the controls work. All of the dial cords are broken. But if you notice that this has got a wobble to it, so this knob something has fallen on it, or it's struck, or something funny is going on inside that knob. I'm not sure if it's the shaft that's bent, or the knob has been drilled off center and somebody put an insert in it. I don't know what's going on until I get the knob off. Who knows? But I don't see that as a horrible thing. I might have a spare shaft if the shaft is bent. If I don't have a spare shaft, maybe I can straighten this one. And if I can't straighten this one, I got a little lathe I could make a shaft if I had to. It's not a big deal. So let's take a look in the back next. Okay, here we are, peering in the back here. So, first thing we want to do, I don't know, you can see all this rat's nest, all the dial cords are broken or falling off here, is we want to close down these tuning capacitors to protect them, that we don't damage or bend them. And since I'm talking about this tuning capacitor, I should have showed you on the front something that I noticed, but I'll show you now. That the whole dial, the green dial you saw on the front, has moved over to the right. And that's because there's rubber grommets here and just in behind here that fail. Of course, it's a tube radio, it gets hot. The chassis warms up, the rubber gets soft, and the whole tuning capacitor begins to drift to the right. So the dial cords back off, and the dial accuracy disappears. Because of course you've calibrated to the red line on the glass of the case, and if the dial and old tuning capacitor moves, well, your dial calibration is completely gone. So there's a rubber grommet in the back. I usually replace this one with a grommet. They're easy to find. You can get them off Amazon. But the front ones, I don't put grommets back in. I put a washer and a spacer in, and I get the dial bezel centered in the window, and I lock it down so that when I do my final tuning and I do my dial calibration accuracy alignment, that the calibration stays, the dial cord stays, But that's just an issue with some of the Hallicraft radios that are like this. The SX99, the S40s. I'm sure there's more that have this issue. And again, the old guys chew on me for not putting a proper grommet back in. But I'd rather have my dial calibration kept and have a functional radio than having the rubber back in, to be honest with you. And you really can't notice a difference. So it looks good. I don't see anything missing. I did see that that shaft is bent. My camera tripod is up against the knob, and I would show you here now that when you turn this here, the shaft just at the output end of that is unfortunately bent. So if I can straighten it or replace it or machine a new one, I will. It's not a big deal, really. You know, probably going to be able to straighten it. And I'll point out another thing. These are the IF transformers. There are 3 of them. And these are the new style IF transformers. The old ones, like I did an S40A restore here on my channel. You can go back and look at, and you can see the size difference. The S40A transformers are much larger. Somebody whispered in my ear a long time ago that these ones are more efficient. They have less loss across them, and they have a tighter bandwidth than the old ones. I haven't confirmed that, but somebody's whispered in my ear that might be the case. Now, the thing that's different between the old IF transformers and these ones is the old ones had 2 trimmer capacitors at the top of them to tune them. These ones here have a ferrite core, a slug that you tune with a tool. They are prone to getting stuck. There is often one slug in the top and one slug in the bottom. And there are tricks you can use to free them. But the big takeaway that I'm going to tell you about, and you need to really heed this warning, this one's not so bad because you can tune these with a slot type driver. The ferrite cores are very, very fragile. If you just look at them the wrong way, they're easy to shatter and break. Some of the newer equipment have a ferrite core that you can drop a plastic hex tool into. And if they are stuck and you apply even just a little bit too much force, they will break. And you will be in trouble. You know, if you don't have a spare one, I mean, breaking one up and picking one out is easy enough, but having another spare core with the right consistency, these ferrites are designed for given frequency range, so you got to put the right one back in. So there are tricks to unsticking these, and for sure, I can guarantee you that these ones will be stuck, and we'll have to trick them loose. So that's really great that we don't see anything here now. I'm looking at the back of the speaker; it looks okay. So the next thing we're going to do is I'm going to pull all the tubes out of it, including the rectifier tube, and that's important because in this step 1, we're going to test the power transformer. And in order to do that, we're going to need to plug it in. And in order to plug it in safely, if we pull the rectifier tube and all the rest of the tubes, nothing can be damaged really. Everything is disconnected. Other than probably the dial indicator lights may glow if the 6.3 filament is working. So in the transformer, we're going to confirm high voltage is there. We're going to confirm that 5 volts is there for the filament for the rectifier tube, and we're going to confirm that 6.3 volts is there for, of course, the filament. Once we get through that, you know, we're going to look at the bottom, we're going to look at the band switch, we're going to look at all the switching underneath, we're going to see if anybody's done any work or if there's any red flags. We're going to test the power transformer. We may look at the IF transformers with an ohms meter. We may look at the speaker and the output transformer with an ohms meter. We're going to just go through and make sure that everything's looking all right. So the next stop for this bad boy is for me to take the cover off. So I will return when I get that done. Okay, with the cover off, things look great. It was nice to see when I took the cover off that all of the original screws were there. And it wasn't chewed up and chewed upon or over the years, so this hasn't been molested that much. I did notice they had taken the cover off the alignment point, so maybe somebody tried to align it once upon a time. But here's what I see. Of course, right off the bat, and to the folks who've recently watched some of my other videos, we can see we're full of wax paper capacitors that absolutely have to go. They short out, they leak, they do all kinds of bad things. They have to go. So, but it's original. I don't see anybody has done any repair work or any tinkering with it. It's great. I'm looking at the band switch. The band switch looks great. A little cleanup with the band switch will be fine. Now, what I did notice was there's a few of these compression capacitors here that have just a weeny little bit of corrosion with them, but that's easy to fix up, clean up, not a big problem. Doesn't frighten me in the least. So I'm not seeing anything that's going to stop us from doing restore. So our next step is we're going to check all three voltages on the power transformer. Now, I don't know if you can notice here, I've already pulled all the tubes out of it. So the power transformer is not connected to anything. So when we apply power, it's going to activate the transformer, and the voltage coming out of it isn't going to do anything. It's not going to create any shorts because all the tubes are out of it. But just a little side note here. This is the rectifier tube. I don't know if you can see it on camera, but I'll point it to you. It's the plastic Bakelite base here has got a crack in it. This is kind of semi-common. Now, if this tube tests good, we can clean it up with some isopropanol alcohol, and we can put a bead of cyanoacrylates like crazy glue around the edge and through the crack to save it. But it underscores the need that when you're pulling this type of a tube with a base like this, that you don't pull from the glass, you pull from the plastic. Because often, yeah, this one's not connected. The glass and the glue that the manufacturer originally used has given up the ghost over the time, and that's the rectifier tube. This is the audio output tube with the 6K6. It's not cracked. It's still well glued, so we'll see. It's original tube, Helicrafter. Kind of nice, kind of nice. It's nice to not have a radio that's been molested. So what we're going to do is we're going to go to the schematic next, and we're going to show you the things we're going to check and where we're going to check them, and we're going to get that done. Okay, here we're looking at the schematic for the Helicrafter S40B. This is the nicest one I can find. I'll be posting this to the file section on my Facebook page in a few days. So if you want to download it and follow along, please feel absolutely free. You're welcome. But let's zoom in and look at the power supply here first. I guess I have to use these buttons here. I guess we can zoom in a little closer. So here's the power supply. Here's the 120 volt side that you plug in. Here's the power transformer. And there are 3 coils output of that transformer. We have this one here, which drives the dial lights and the filaments. It makes the tubes glow at 6.3 volts. We have the main one here. This is AC, and if my memory serves me correctly, at 120 volts input, I should see around 320 volts AC on these 2 terminals. This is the filament for the rectifier tube, which is 5 volts. So we should also see 5, or when it's unplugged, maybe 5.5 volts or so on these. So we're gonna, with this tube removed and all the other tube removed except for the dial lights, I feel safe enough that I can plug this in. I'm not going to break anything. And I can check to see if I have my 5 volts and my 320 volts AC and my 6.3 volts. That way I know the power transformer is good. Now, other things that you can do while you're here just to be sure things are going down the highway properly, you can go across the input, the primary side of the audio input transformer, and see if you have continuity. I don't know what the resistance is, but if you've got continuity with the tube removed, you know that your input side is good. You can do the same thing here. You can go across these two here with the output side. And if you've got continuity, then you know your coil and your speaker and your secondary on the audio output is okay. You can also go across the output terminals on your IF transformers to make sure you've got continuity. And you can do that very quickly. And again, we don't know what the spec is, and all we're looking for is continuity. So if you've got continuity going across these, it should be all right. It should be okay. There are capacitors inside that could be shorted. I mean, I don't want to get into a discussion about silver mica disease, but these new IF transformers have a little capacitor inside that's little wedges of silver mica. And if the radio is stored in a moist or wet environment, they can corrode and they can cause problems, and it can be a real nightmare to deal with. You have to take the transformer out, and you can take the silver micas right out of them and then resolder new silver micas once you try to figure out what the value is across the bottom. So it's not a completely lost scenario. It's just a little bit more work and a little bit more fooling around. You can save it. So that's what we're going to do. We're going to go to the bench next, and we're going to do the power first, and we're going to do a couple of quick checks just to show you how we're going to just check the IF transformers, check the audio output transformer, as just part of step one of making sure that you're going to invest all your time and money in replacing all these capacitors and probably some resistors, and that you're going to have a working radio come out the other side. So let's head back to the bench. First thing we're going to look at is high voltage coming out of the power transformer. I'm clipped onto the two red leads on the bottom of the rectifier tube, and I'm going to apply 120 volts, and we're going to read off what our transformer is putting out. Now, before you do that, the cord on this unit is not great, but it's safe enough for a test. So you need to ensure yourself that the cord is not cracked and it's not going to touch something, and you're not going to electrocute yourself. So make sure that the cord is reasonable for this test. Again, all the tubes are out of it, so we can't hurt anything. And all we can really do is check our power supply transformer. So I'm going to turn the variac on in the background behind my trusty Simpsons 260, and we'll see what we get. So right off the bat, you can't see it, but I can see both dial lights have come on, which tells me my 6.3 filament voltage output of the transformer is working. And I can also see I have deflection on the meter here, and I have just about precisely 320 volts, which is great. That tells me that the high voltage side of this transformer is working, which is wonderful. So what I'm going to do is I'm going to shut the power back off. Then we're going to clip on to the two yellow golden leads going to the rectifier transformer. And this is going to check our 5-volt filament for the rectifier tube. It has a special filament voltage. I mean, it's going to be a little high, maybe 5.5 or whatever, I would believe, because it's not loaded down. The tube is not plugged in. So we'll just shut the 120 volts back off again. We'll give it a second for the voltage to clear. And we'll move our leads over to the 5-volt filament, with the golden ones down here. Dum, 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 dum. That should be it. I'm going to leave that on high voltage just in case there's a short. Our power is back on. I'm on the 10-volt scale. What am I showing here now? I'm showing 5.4 volts or so, which is pretty normal. Like I said, the tube's not plugged in, it's not loaded down. So now we know the radio is reasonably complete. There's really nothing missing. We've got the one bent shaft to deal with. There's been no Tom butchery happen here within the chassis. We know that the output transformer is working great. So we're just going to do a couple of quick checks. You can go more extensive on your radio now that you know what to do. We're going to look at the audio output transformer. Let's see if it's got continuity. And we'll look at one of the IF transformers and we'll see if it's got continuity. I'll do them all off screen, but I don't want to bore the pants off you. You guys are smart and you can figure this stuff out. So we'll turn this off here. And we'll give it a second or two for everything to clear. Now, just as a safety factor. I don't know how well you can see it here, but there is the large filter capacitor here mounted on the chassis. And the next step we're going to be dealing with this, but not in this video. But this capacitor has the potential to store 360 volt DC, will and can still be present well after you turn this machine off. You can get a serious shock all the way up to being lethal if you're not careful and you don't discharge that capacitor, or if it sits on the shelf for a long time, it may slowly bleed off. But having what I call a Jesus stick, which is like a test probe with a ground clip and a resistor in path where you can then clip onto ground and touch to each of the terminals and short that capacitor out or drain it off safely. But it is a place where a lot of new folks get burnt, or at least they're good first shock. So I'm alerting this to you that this is not something that you really want to do. You can make a Jesus stick, as I call it, because if you don't use a Jesus stick, you may be going to meet him. Let's just have a look here and see what we can do with our cheap ohms meter here. And I like test gear. I've got a lot better test gear in my other shop. This is just my video shop here. And the idea of the gear that I have here is just affordable and simple to show you folks that you don't have to spend $1 million to do this type of stuff. So here's my audio output transformer. Here are the primary leads coming out of it. They are blue and they are red. So I've got one on this terminal here and another blue one. And I have continuity, so I know that end of the audio output transformer is working. Let me just have a quick look here. This is one of the, and I have continuity across that. I won't go through them all, but you can with yours, just to be sure. I will do that off camera, but I'm probably pretty sure that this radio is in good nick. Okay, so we know a bunch of things now. We know that the radio appears to be quite salvageable. So I'm going to continue the disassembly. I'm going to take the front faceplate off it, all the knobs and dials and everything else, so that we can clean it. And we're going to prep it all in a box with our screws that we took out from the chassis. And now we're going to go through the tubes. We're going to see if we need to replace any. Okay, let me tell you another story about tubes. A lot of new folks think, oh, I'll run out to the marketplace and I'll buy all brand new tubes. That's not a great idea. Often the tubes that are in the radio are better than the ones you're going to buy. Now, if you have to replace a tube or two after testing, so be it. It happens. It's frequent. But some of the tubes that are being sold out there aren't great. And I've mentioned this before. Some may disagree with me, but this has been my experiences. Jan tubes that were made for the military. Like here's a 5OI3 rectifier that tested very poorly. It was brand new. So I steer clear of Jan tubes now. When I buy tubes, I buy new old stock or used, like Sylvania, like Westinghouse, like RCA, like Raytheon, like Marconi. The originals in the original boxes, these tend to do better than the Jan tubes. This is my personal experience. Maybe it's not yours, but unless I'm absolutely forced to, I won't be buying any more Jan tubes. The next thing is we're going to get the knobs off it, and we're going to get the faceplate off it so that it can be cleaned, as I said. And I'll come back when I get that done. Okay, so maybe we'll take a moment and we'll talk about taking the knobs off of helicrafters and other communications receivers. It's always kind of a tense time for me. Often somebody who's not very astute or not very handy has attempted to take the knobs off in the past, and they've chewed up the fastener bad. It didn't happen in this case, which is nice, brings my stress level down, but let's talk about that in the first place. A lot of the early S38s had a similar looking knob, but it just used a small screwdriver to undo a set screw. And then as Hallicrafter got a little bit older and a little bit wiser, they began using Allen keys. And you must make sure you have the correct size of Allen key, because if somebody's kind of chewed it up even a little bit, you want to make sure it fits properly and you're in all the way, and that you've used a little can of compressed air to blow dust out. Use a little pick tool to pick the dust out if you have to, because you want to get that Allen key in all the way to the bottom. And they usually release with a little bit of snap if they've been on there for a while. So that's real important that you use the right size Allen key. Now, I had mentioned it earlier in this video about the band switch knob here. Yes, it's original. I've seen a couple of factory photos with this knob on, which kind of really surprises me because it was one Allen key size up, and it's a double set, which is kind of nice for that. It's a good heavy duty knob, original factory. It come off with ease. Now, the Allen keys are the second step for Hallicrafter. The third step, which like with the SX99 or the SX100, a lot of the newer, fancier, more expensive Hallicrafters use a little fastener that looks like an Allen key, but when you look at it real close, it starts to look like a Torx, but it's really not. It's a Bristol wrench. I don't think you can really see very well on camera. It looks like a Torx bit, but it's not. It's its own thing. So you have to be prepared for that when you're working on Hallicrafter, that you've got to identify what type of fastener your knob has. It's either going to be a straight flat screwdriver, an Allen key, or a Bristol wrench. So just a heads up. So next I'm going to take this face panel off, and I'll be back in a minute. Okay, we got the faceplate off, we got the dials off, we got the speaker off the front panel. The front panel itself is going to clean up great, and on this one all I'm going to use is soap and water and a soft cloth to clean both sides of this. And that should be fine. Some people have restored radios already. They use a water slide decal to replace the lettering, and water can take them off. So be sure that you're dealing with the original lettering and easy, gentle soap water. The dials, I have seen, the dials are in good shape. I have seen some of dials actually be affected by regular soap and water. So I just dusted these, and that's as far as I'm going to go. They're clean, they're nice. If you feel your dials really need to be cleaned, experiment and try with just like your regular old water first. Certainly not Windex or anything ammonia based. You may cry if you do that. The speaker's in great shape. Usually I expect a split or two, but there isn't. I don't see any problems with the speaker. Let's hope the voice coil doesn't rattle. Looking at the chassis, nothing earth-shattering that we hadn't discovered already. We already know that the grommets in this capacitor here are loose. You can see that it's moving quite a bit here now. I don't know if you can see this on camera. Maybe I'll get in a little closer to this, and you can see that this shaft here is definitely bent. Just 1 second, let me see if I can zoom in on that. So here's the suspect shaft here, and you can clearly see it's wobbling. So I'll either straighten this, or maybe I might have a spare, and if not, I'll just machine another. It's not a big deal. I'm sure most people would be able to straighten this. If you've got a little mini lathe, you can maybe bump straighten it. Not a huge deal, so we'll get that fixed up. Okay, well the good news is I've tested all the tubes, and all of the tubes test really strong except for one, which is an S6SC7, sorry about that. It is the audio pre-driver in front of the final audio output tube. And it's not testing great. It tests 68, both of the triodes. I found another. The tube was kind of ugly looking. Now maybe I have more I can dig through, but this is the first one that I pulled out of my goodie box. Let's let it heat up a little bit. Let's get the filament warm and we'll test it. It's showing 70. The other one was showing 68. Still slowly climbing. Let's let it warm up a little bit more, but maybe I've got even a better one somewhere in one of my other collections of these old tin can tubes here. There we go. It's warming up. It's coming up towards 75. So that one's acceptable for me to go ahead and use. Just not pretty. But I'll see if I can find one that tests good. And it is pretty eventually, but nevertheless, I've got one to test with. The original one will probably work. It's not in a critical location like the mixer tube on these sets are extremely critical, but all the other tubes test quite strong. So that was nice that you're not going to have to shell out a bunch of money on tubes. So wrapping this up, we know that we have a set that we can restore. There's no missing or broken unobtainium that's going to stop us, so we can move ahead to the second step. We know that we have one bent shaft that we can deal with. We know we probably have 3 stuck IF transformers, which I'll work a magic trick on to unstick them. We know that the main tuning cap is loose, which is not a big deal. We'll get it tightened down, and the face plate and the dials and everything are good. So, we give this definitely 2 thumbs up to move forward for restoration. So with that, we kind of sort of know what we need. We can make up a parts list, get parts. For me, I have most of this stuff in stock. I believe I can proceed right away to restoration, but other folks may have to make up a part list. I prefer to keep the stock because I wind up doing a lot of this type of stuff for folks and my own consumption, of course. So with that, this is my step 1 completed. Next video will be step 2, and we'll go into that probably next week. So until then, thanks for tuning in. We'll see you again.